So let's look at an interesting shape called the cone, the surface area of the cone. So, sphere had a wild way of doing it. So does a cone. But let's see if we, again, understand how to find the surface area of a cone. So again, the surface area is the total area covering the outside. For us, there's going to be a circular base and there's just going to be this curved lateral face. Okay. So let me see if I can take us to that there. Let me see if I can find that. I really can't find it. I thought I knew where it was. Now I don't. So let's look at this cone here. Let me see if I can get this thing to maximize for us. Get all the commercials out of the way. See if I can get my stuff out of the way. So notice how, again, we have this bottom face is a circle. So we already kind of know that, hey, we kind of know that's going to be this area is going to be this pi r squared for the bottom. Now the catch is this lateral face going across here. So what we can do is if we unfold this, we start to see the shape of this. Notice how if we put this back together, we have what we call this slanted height here. So in this area here, oh, just hit something. What did I do? Looks like I reorientated it. There you go. Let's keep it like that. So notice how here we have what's called a slant height, which usually they use the letter L. Now, if I keep unfolding it, notice that this bottom edge is the circumference around the circle. So if I unfold it, so notice how this distance is actually going to be the slant height, and this is actually going to be the circumference of the circle. So see if I can get this thing to move a little bit more. All my things are being blocked. Let's see here. All right, so I think that's all that one's going to show us here. Let me go to the other one here. All right, let's close this one out. Let's unfold this one here. So if we bring this out like this, we get that. Yeah, this is what I want. So this helps us this is going to help us kind of see how to determine the area of this lateral face. So as I said, this distance is the length, and this distance is 2 pi r. But notice how this is an irregular shape. So we really want to find out how to figure out the area of this irregular shape. So what I can do is try to get rid of these advertisements, but it looks like I can't. So notice how we want to find the area of this irregular shape here. Notice how right now it looks like a Pac-Man. Now what I can do is straighten out the arc so I can flatten this out. And remember that distance is going to be 2 pi r. So from there, what I can do is dissect this sector. I can cut it into pieces. And we can cut it into more pieces. Let's just cut it into about 20. So once I have about 20, what I can do is, again, we're talking about, this is what we're trying to do is find the area of this. If I unfold this area, notice how it starts to take on this shape. So now it's a bunch of little triangles. But notice how if I keep on rearranging, notice how it turns into kind of a rectangular shape. So notice that this distance is the length. And remember 2 pi r was this total length. So this length now is actually just simply um, pi r. So to find that area that wraparound, it looks like it's going to be this length times this pi r. So the surface area would be pi r squared to determine the area of the base, but then you got to add to that this pi r this pi r times this L, because notice how this distance is actually half of the circumference. It only goes half the distance because that if we unravel it again, notice how this is the total distance, which is 2 pi r. But if I keep rearranging it, notice how that half of it goes to the top and half of it's on the bottom. So this is now pi r. So our formula for surface area is 2 pi r. Okay. But now, if I go back, let's see if I can get this, go back to the top there. So if we go back to this, let me erase some of this here again. It's always something technical. Go away. Let's see. So if we look at this, if I bring this back together, let's see here. Let's see if we can reset this thing somewhere. Let's see if it will let us reset this thing. Let's reset that, but not that. So let me close this out real quick here one more time. So unfunding the code, I think it's this one here again. So notice how in the original position of the cone, we have the height of the cone, which is the distance from the top of the cone to the center of the base. We also have the radius, which comes out from the center of the base out to the edge of the cone. And we also have this slant height, which is the distance across the slanted part of the cone. Notice how this is a right triangle. So in a right triangle, we know that a squared plus b squared equals c squared, where again, the c was the hypotenuse and a and b were the legs. So notice how the slant height is actually our hypotenuse. So notice how we can write this as, using the Pythagorean theorem, L squared is equal to then this h squared plus this r squared. So notice that the L can be found if I know the height and the radius by using Pythagorean theorem. But to get L by itself, we would have to take the square of both sides. So the lateral height would be the square root of, or the lateral distance, if you will, that slant height would be the square root of h squared plus r squared. So in our formula, we kind of said that the surface area was pi r squared, plus then to find that lateral face, it was pi r times L. But notice how we can actually modify this to be pi r squared plus pi r. Instead of L, we can write this as times then the square root of h squared plus r squared. So really, technically, we only need to know the height and the radius to find the surface area. I don't have to know the slant height because I can use the Pythagorean theorem to find the slant height. So this formula, based on what's given, has a couple of different versions of it. So as we close out here on this, get rid of some of this here. Still a little slow on all this. So notice that we pick up on in our book that the formula you'll see if you use the textbook is the surface area So the surface area is going to be this pi times the square root of r squared plus h squared, which remember, that's going to replace the slant height if we don't know the slant height. So this part here represents that irregular shaped surface that wrap around the base. And then the r squared represents the pi r squared represents the area of the base. So that determines our surface area formula. So you'll see that if you look at the textbook.